No, I can't. Your video is not on. Anyways, it'll be good if you switch it on. Okay, okay. So Saksham, what is going on in your school these days? Which topic is going on? In exams going. Okay, okay. Just a minute. If you increase temperature of a cylinder which contain a gas, what will happen? Yeah, suppose if I talk about your kitchen cylinder, okay, will it explode immediately as you start heating it, or will it take some time to explode? Why will it take some time? Okay, I'm sharing my screen. Can you see my screen? Right. Here is a cylinder which contains some gas, right? Here I have put a piston. If I rise the temperature, every molecule, its kinetic energy will increase. It'll move with more kinetic energy. It'll move with more kinetic energy. Kinetic energy will increase. I can say it's a Brownian motion will increase. What is Brownian motion? Do you know what is Brownian motion? Uh, yeah, zigzag motion. This motion will increase and it'll push the piston, it'll push the wall, push all the walls with more force. This piston is movable, so the piston will move up. You got it now? But in the in a cylinder that you have in your kitchen, it does not have a movable piston. Its volume is fixed. It's like volume is fixed. And there's a gas inside. These particles are pushing the piston with more force. The material of the gas of the cylinder has certain strength. It can withhold certain pressure. But after a particular pressure, this will blast. This will blast. Am I clear? Right. It means with a rise in temperature, the volume of this gas cylinder will increase. I can say if it is fitted with a piston. If I rise the temperature, the particles are pushing the piston and the volume will increase. Right. It means I can say volume of a given mass of a gas is directly proportional to temperature applied over it. Right. This is known as the Charles law. Write down. At constant pressure, volume of a given mass of a gas is directly proportional to temperature applied over it. Is directly proportional to temperature applied over it. The volume is directly proportional to temperature. Is that clear? Have you noted down? So I'm stopping sharing for some time. Yes, Nipun. All of it turn on video. Why do you stop? Okay. If you rise the temperature, the volume of a gas will increase, right? Okay. This I have shown in with a diagram and all that. Have you ever observed that whenever there is more temperature in our surrounding, after some time there is a wind flow? Have you ever observed this? Yes or no? The day on which the temperature is high, it's a very hot day. On the same day or next day, strong wind flows in your area. Yes or no? Have you observed this? Nipun. Okay. Taksham, have you ever observed? No. Okay. I will not tell you what actually happens if you have not seen. Wait. Suppose I say this is the area where we are living, right? This is the atmosphere here. The day on which temperature is high, the gas particles, their kinetic energy increases and the gas moves more volume, more occupies more volume, it moves up. If it moves up, the pressure here decreases. And have you ever observed on such day you feel more suffocation? And suddenly, after some time, you can feel that the air is flowing toward that region. From the region of the high pressure to the low pressure, the gas moves in. The air moves from the region of the high pressure to the low pressure. Have you observed this? Okay, I repeat. I repeat. I understand that you are not getting right now. Understand. I again repeat. This is the earth and this is the region where we are living. Let it be. Let it be. I'm living in Chandigarh, right? I'm living in Chandigarh. This is the region. And today temperature is high as compared to other days. When temperature becomes more, the gas occupies more volume because right now I have told you that volume is directly proportional to temperature. More the temperature I do, the more the volume. Am I clear? It means the air that is on the near the earth's surface that expands, and as the air occupies more volume, the pressure drops. Is that clear? And due to the pressure drop, you feel more sweating and more suffocation. Have you ever observed this? More sweating on a particular day? If you're not living in an air conditioned room, openly, normally, have you ever observed this? No, I'm stopping sharing. No. Okay, turn on the videos. Okay, right now are you sitting in an air conditioned room? Huh? Saksham? No, normal room. Okay. Uh, Saksham, you tell me which city you are in right now. Pardon? Bangalore. Okay. Nippon. Okay. Arav. Arav. Okay. What is the temperature of Bangalore today? Around? Okay, 25 degrees Celsius. Okay. It is humid atmosphere or a dry one? Atmosphere today. Uh, what is your atmospheric humidity? It is humid or it is dry or normal? Normal. It means you're not feeling any sweating? No, no sweating. Do you feel on a particular some days in Bangalore that you feel sweating? Some days. Okay. Why do you feel sweating on these days? Without any heart, without any physical work, you feel sweating. Yes or no? Right? Why do you feel that sweating on some days? Repeat, Nipun. Hmm. Okay. Why does sweat come out from our body? Why sweat come out? Why do you sweat? Why liquid comes out? Hmm. Hmm. That's the consequence. But why does liquid come out of body? Suppose my hand is here, it's sweating. The liquid is coming out of my skin. No, no. It'll evaporate only when it comes on the skin. It'll evaporate only when it comes on the skin. But why will it come out from my muscles? Yes, Aksham. Okay. Yeah, after the cooling effect, when evaporation is going, it will cause the cooling. That's all okay. Arav, can you tell me something? Arav, I can't hear you, see you. Okay, now understand what happens here now. The day when the temperature is high, the air in my surrounding will occupy more volume, and in my surrounding the area, the volume of the air will decrease. Means the air content will decrease, right? So the pressure will decrease. Can I say? Because less gas is there, less pressure is there. It means around my body, the pressure of the atmosphere is less than 1 atmosphere now. Inside my body, there's a high pressure due to my blood pressure. There's a high pressure, and that is why from the region of the high pressure inside the body and outside of the low pressure, the gas will come out, the liquid will come out. Just like diffusion, yes, it is just like diffusion. But the movement of the movement of liquid will take place from the region of the high pressure to the low pressure, and this is called as a like diffusion process. Am I clear? So we feel more sweating. So the movement of the gas, movement of liquid will take place from the region of high pressure to the low pressure. That is why we sweat. Liquid come out of the body. Now, another point now. Similarly, if I again sharing my screen with you, sorry, this one. In this region, today temperature is high. The air will occupy now more volume, and that is why the pressure will decrease. And here in the another region, outside Chandigarh, um, where of the air is high, so air will move from the region of the high pressure to the low pressure. Air will move from the region of the high pressure to the low pressure. This is called as a movement of the air. That is we call it wind. Why wind moves? Why air becomes wind? Why air moves? It is because the movement of the air from the region of the high pressure to the low pressure. Am I clear? Yeah. Okay. Another point. We can show it like this way also. Um, you have some gas in your gas cylinder, right? There's some gas in a gas cylinder. When you turn it on, what happens? Yes, Nipun. Arav. Saksham. Yes, Saksham. Can you hear me? Okay. I asked one simple question. When you turn on the knob of the gas cylinder, what will happen? Yes, Nipun. No. You have in your kitchen there is a gas cylinder and a gas stove, right? You ju- you turn on the gas cylinder knob, right? And also that stove also turn on. What will happen? It will. Nipun, you tell me. Okay, I tell you what is mean knob of. I'm sharing my screen. This is your gas cylinder, and above it you can find there is a uh, one what you call as a. You can rotate it, and the gas will come out of the pipe. Yes or no? And then it is connected to the stove. So when it turn on, the gas moves out of the cylinder and comes over here. And here you ignite it, and there is a fire over here. Yes or no? Have you observed this in the kitchen? So why is this gas coming out from this cylinder to the outside? Why is this gas coming out? What drives the gas to come out from this cylinder to come out and come out of this cylinder and through the pipe it is coming to the stove? What is the force? What is the yeah, exactly. So the high pressure here inside the cylinder, and here we have low pressure outside, so the gas will come out. Gas will come out from the region of the high pressure to the low pressure. From the region of the high pressure to the low pressure. This is called as a movement of the gas from high pressure to the low pressure. Same way it happens here also. When the temperature is high, the air of my region, my city, has expanded. It occupies more volume in the sky. And here the pressure drops. In the another region, the pressure is high of the air. So the gas moves from the region of the high pressure to the low pressure. Am I clear? All right. Another very simple, funny example I will give you. Why, why do we yawn? You know, yawning. The gas comes out of our body. Why do we yawn? Yes, Nipun? Yawning. Yeah, are you understanding me? Yawning mean? Okay. Why do you yawn? No. Inside our body, due to the respiration of the food, there's a lot of carbon dioxide get accumulated in our blood vessels. And outside pressure is less. And inside pressure becomes more, the gas comes out from the region of the high pressure to the low pressure. So it comes out. Yeah. Yeah. So whatever the carbon. No, sleeping is another thing. But normally, even though we are fresh, we are not feeling sleepy. We are just got up from the bed now, right? Just before your class at 4 o'clock, at roughly 3:45, before up to, between 2 and 3:45, I was sleeping. Okay, when I got up at 3:45, just before your class, I felt yawning. No, it is not tiredness or something. The reason is the inside our body, the respiration is going on, and the food that we take that undergoes combustion, and carbon dioxide is produced. That carbon dioxide pressure inside my lungs and the body is more than the outside. The pressure inside is more, outside is less. So the pressure from the region of the high pressure from inside to the low pressure outside, the carbon dioxide comes out. Right, this is the yawning, right? I'm giving you different examples, right? Getting me, Arav? Arav is not speaking. Why? Arav, are you there? Okay. Right, Saksham. Now I am demonstrating one experiment, the effect of the temperature on the hot soap bubble. I'm giving an example of a hot soap bubble. You can perform this experiment later, right? Hot soap bubble. You need just a soap solution, an empty glass bottle. It may be available at your place. Right, right. Yeah, after my class, you can perform it. Yeah, soap and water. That's it. Soap dissolved in water. That's it. Now, what did you that make sure that bottle is clean and empty? Bottle is clean and empty. Make it sure that bottle is clean and empty. Take a small amount of soap on your finger by dipping it in soap solution and slide the finger on the mouth of the bottle to make a thin film of the soap. What will happen on the top of the mouth of the bottle? There will be thin soap layer. Thin soap layer. Am I clear? It will be like this. And make sure that thin film of the soap completely covers the mouth of the bottle. And now hold the bottle in such a way that your hand completely touch the bottle from all sides. Right? Your body temperature, your body heat will increase the temperature of the air inside the bottle. Will increase the air inside the bottle, and expand this will expand the air. As the air expand, you can see the layer, the flow bubble also expand. If you keep on rising temperature of the air, the volume of the bubble will increase. Are you getting this? Will it happen? Yes or no? It would be good if you do it yourself. You just don't need much things. Just a bottle and a soap water. Right? And then what has actually happened? Heat from the hand causes expansion of the air inside the bottle, and this results in the formation of bubble from soap solution. Now go through it. Just go through it. The air inside the bottle is initially at 25 degrees Celsius. When it touches the bottle, due to high temperature, the bottle inside gets heated, and that causes the expansion of the air and the soap bubble to make like a bubble. Like, am I clear? Okay. Yes, Nipun, are you getting this? Right. This is how the volume and temperature are related with each other, and we call that a volume of a given mass of a gas is directly proportional to temperature applied over it. So volume is equal to some constant K into T. K is a constant, or I can say V1 V upon T is equal to constant. Right? This T is in the Kelvin scale. Do you know what is Kelvin scale? If I had 25 degrees Celsius, how will you represent it in the Kelvin scale? No, I will not give you conversion factor. 273.15 plus degrees Cel- temperature in degrees Celsius is equal to temperature in the Kelvin scale. I have not. Wait. Now, right. So this is the temperature in the Kelvin scale. 273.15 plus temperature in degrees Celsius is equal to temperature in Kelvin scale. You can delete it, no problem. You can omit it. But normally, exactly it is like this. Otherwise, you can omit out on 0.15. Now, I told you that how to convert degrees Celsius into Kelvin scale. 25 degrees Celsius. So put here 25, you will get here 298 Kelvin plus 25 degrees Celsius. So it is a temperature in the Kelvin scale. 298 Kelvin. Am I clear? Yeah, I'll tell you what it represent. Actually, what we have done. We draw a graph between the temperature in degrees Celsius and the volume. If I have a temperature, let it be 25 degrees Celsius, and I have water vapors here, right? Water vapor or any gas is there. If I decrease the temperature, what will happen to the volume? What will happen to the volume? Volume will decrease? Yes or no? Because I told you that volume and temperature are directly proportional. If I raise the temperature, volume will increase. If I decrease the temperature, volume will decrease. So what I do is I keep on decreasing the volume, I keep on decreasing the temperature, the volume goes on decreasing. At 0 degrees Celsius, the volume of the gas does not become zero. The volume of the gas does not become zero. Am I clear? Right. Because the region where temperature is 0 degrees Celsius, there is air, there is still air. Yes or not? For example, if I further decrease temperature, let it minus 10, minus 20, minus 30, there also the air is there. In Ladakh, right now, temperature is minus 40 degrees Celsius, but still air is there. Our soldiers, some people are living over there, right? So, what I do is I keep on decreasing temperature, the volume goes on decreasing. I can decrease the volume, I can decrease the temperature to certain limit, and after that, I can extra plot it. Where the volume sees to zero, the volume of the gas becomes zero, and that temperature is now minus 273.15 degrees Celsius. At this temperature, the volume of the gas becomes zero. At this temperature, volume of the gas becomes zero, and this is called as an absolute temperature. This is called as absolute temperature. Am I clear? Right. It means if I come to 0 degrees Celsius, I had to cover this much. So 0 degrees Celsius is equal to 273.15 degrees Celsius, right? Kelvin scale. This is called as 0 Kelvin. This is called as a 0 Kelvin. This temperature is called as a 0 Kelvin. Minus 273.15 degrees Celsius is called as a 0 Kelvin. Minus 273.15 degrees Celsius is equal to 0 Kelvin. I hope it's clear now. Yes or no? So if I say I have a 35 degrees Celsius, convert into Kelvin scale. You can omit it, no problem. 273, take 273 only. Good. 273. Yeah. So you can now say 308 Kelvin. Okay. If I say I am having minus 5 degrees Celsius, convert into Kelvin scale. Good. Very good. 273 minus 5 is equal to temperature in the Kelvin scale. That comes out to be 268. Okay, that's how you have to convert, right? So from this experiment, we have come to this conclusion that volume and temperature are directly proportional to each other. Am I clear? This is called as a Charles law. This is called as a Charles law. Done? Understood? Arav, are you there? Arav, I don't know. Okay, Ripun and Saksham, tell me, any doubt till now? No. Okay, then I'll now give you some question practice. I'm sharing my question, my screen now. Can you see my screen? Saksham, can you see my screen? Okay. Yeah. Arav, you leave and join again. Arav, you can leave and join again. Okay, now here's the question. Good. Yes. Yes. Work upon this question. Yes. How have you done? Good. So tell me, 90? 85. 85. Okay, next. Good. Solid, liquid, gas. Exothermic means? Yeah. So, which? No, that is endothermic. It is absorbing heat, right? So that will not. No, no, that will not show the exothermic. Yeah. No, no, that will not show the A will not show the exothermic. That is the endothermic. We are heating it to get boiled. Uh, I think all of this. All of this. Yeah. Okay. Mm, 1 and 3. Yeah, A option. Carbon dioxide is a gas, methane is a gas. And gases have weakest interparticular force of attraction. Mm. Yes. Hello. Yes, Nipul. Okay. Assertion statement is correct. Yes or no? Assertion is true. Have you practically observed this? Hmm. Okay, steam is more, it causes more burn, more severe burn, right? And the reason is the steam has more heat content, right? It is not enthalpy vaporization. So it is A is true, but R is false. No. Kinetic energy particle is the least. D. Freezing of water. Okay, good. Next. Why? Okay, good. Getting me, Saksham? Okay. Shweta put hot iron on the wet shirt. After some time, shirt become dry. Of course, it is evaporation. Yeah, the heat evaporates. What is condensation? Liquid. No. Yeah, gas liquid. Okay. Yeah. Sound. Yes. Yeah. Work upon this question. Okay. Wait. Hmm. B. It means point one is you have to say that it is liquid, right? So if you say minus 60, yeah, point two will be gas. I think all the options should be having some positive value of the second point. That should not be negative value. Hmm? Definite volume but not definite shape. It means temperature, any temperature that is above minus 5.9. All the options are wrong here because this is a melting point is given here. It means at minus 5.9 it will be solid. So all temperatures here are below than minus 5.9. So at all this point it is solid, right? But no definite shape. It means that should be liquid. Uh, all are incorrect here. Getting me? Hmm. Raisins swelled when soaked in water for some time. Yes or no? Yes. What the reason behind that? It's a process of osmosis. Have you heard about this word osmosis? Hmm. Movement of the liquid from its high concentration to low concentration. That is called as an osmosis. It is not a diffusion. Remember this? Understand this, or should I explain? So, because this statement is A statement is correct, but second statement is wrong. The movement of the water takes place inside that resin, and that phenomena is known as a osmosis. It is not diffusion. So, statement A is correct, but B is wrong. Understood? Oh, very simple question. Yeah, cotton one. A option, correct. 700? Hmm. 1 5. This is quite a rough idea, है ना? It should be experimental observation. I'm also choosing roughly because it is not to be crammed. We done this? Yes. Yes. Any idea? Hmm. Understood? Oil in water is a heterogeneous mixture. Yes, you are right because they are making two different layers, so you can use separating funnel. Right, perfect. Yes, Saksham, am I clear or should I explain? Hmm. Do you know how to represent the concentration? Yes, yes, yes. Percentage because you're multiplying with 100, right? Yeah. No, that is called as a soul. That is called as a soul. I will tell you what the meaning of this. Wait a minute. Do you meaning the wait? One thing is you know what you mean by the word solution. Can you tell me what is solution here? Yeah. But the particle size that we are dissolving there is size is less than 1 nanometer. Solute size particle is less than 1 nanometer, then we call that the solution is it is a true solution. But if the particle size lies between 1 nanometer and 1000 nanometer, it is called as a colloidal solution. Simply, it is also called as a sol. So, milk of magnesia is nothing but it is a calcium hydroxide, and its particle size lies in this range. So, we call this is a sol. Understood? Yes or no? And if the particle size is greater than 1000 nanometer, it is called as a suspension. It is called as suspension. It means when you're dissolving sugar in water, that is a true solution. Sugar particle size is less than 1 nanometer. It is a true solution, right? And if the particle size is in between, just like we have foam, we have cream. All these are colloidal solution. And if I say soil or sand in water, that is called as a suspension. Depending upon the size of the particle less than 1 nanometer, 1 nanometer and 1000 nanometer, and greater than 1000 nanometer. Am I clear? Yeah. Sorry. No, this is not the right answer. See, the total volume will become equal to 150. Yes or no? And when half is gone, 75 is left. Out of 75, water is now 25 only. Again, it is 50 grams. Because upon boiling, sugar has not, sugar is not evaporating. Sugar will remain 50 grams. Am I clear? Hello? Yeah, sugar not evaporating. Okay, no. Which is not pure substance. Milk, yeah. Which falling is the element. Which of the following is an element? Yeah. Ishita makes a solution of ammonium chloride in water. She dissolves 52 grams of ammonium chloride in 200 ml of water at 329 Kelvin. Okay. What amount of ammonium chloride is needed to dissolve in? Okay. By unitary method, you can calculate. For 200 milliliter, we need 52. For 400, I need double. Yes or no? Getting me? Okay. Do you know what is Tyndall effect? Yeah, tell me, what is that? Scattering of light by the particles, by the solution particles, colloidal particle particularly. So the solution that is a colloidal solution that shows the Tyndall effect. So which among this is the colloidal solution? Milk, yes. So it is the B option, correct answer. Do you know what is this chromatography? Okay. Yes. Is that? Yeah, it is moving more. It is moving in the aqueous medium more. Getting me? Okay. Yeah. Yes. Can it explain it? Why? Because that is a pure water, right? Pure water has a 100 degrees Celsius as a boiling point, and the yeah, and the freezing point will be 0 degrees Celsius. But if the liquid is boiling at 120, it means that is not a pure water, but that is a solution. It'll boil below 0 degrees Celsius, right? 120 degrees Celsius with the liquid, the water which is boiling at 120 will freeze at minus temperature, -5, -10. Because whenever there is a solute dissolved in solvent, the freezing point decreases. For the pure water, the boiling point is 100 degrees Celsius, and so the freezing point will be 0 degrees Celsius. Okay, getting this? Okay. Student, just give me a minute, man. I'm just coming back. Just coming back. We solve this question. Yes, please. Maximum mass percentage. 45. Yes, you are right. Yes. Do you know the meaning of the fractional distillation? So which gas will come out first? The one which has a minimum boiling point that require nitrogen. The one which will require minimum boiling point will require minimum energy, minimum heat to evaporate. Which is matching here. Butter will be solid and liquid, so we can say it is a gel. It's right, it's gel. Yeah. Which of the following is a lustrous non-metal used to make antiseptic? Yes. Understood? Right. I'm stopping my okay. Turn on the video. We have discussed today one important aspect, effect of temperature on the volume. Volume and temperature are directly proportional to each other. Is that concept clear, Saksham? Nipun? Right. I gave you different examples. I gave you how the gases move from the region of high pressure to the low pressure. Even liquid also move from the region of high pressure to low pressure. What do you call that process? Osmosis, yes. Right. And then I gave you one experiment also, right? That is a soap bubble. And then we practiced some questions today, right? Today level of the question was bit higher. Have you observed that? Right? But you could do it. You could do it, right? And for your Olympiad, such type of multiple choice questions are expected, right? Have you noted down this question or just solved it? Okay, these questions are already given on your platform, on the EduSection platform. You can also redo it. You can attempt it again, right? Okay, so that's all for now. Today I'm ending session. See you next week now with the another topic, atom and molecule. Right? Okay then. I'm